Hello, boys and girls. I'm Dr. Lo. So today we continue with our last chapter, chapter 11, particle physics. For me, the total 11 chapter, this chapter is the easiest chapter lah. Even more easier than the chapter 1. Okay. So at here, first we're talking about the alpha particle scattering experiment. This experiment actually they want to prove that they want to show that what is the structure in the atom. Okay. So the experiment setup is consists of alpha particle. So later on page number 2, I will explain a little bit why alpha particle, why not beta particle, okay? Because this is a quite common question asking by students. But in the past questions, they don't asking about this lah, okay? So alpha particle, so we will have a box, okay? Then the box actually, in year 11, we did learning about this, okay? There is a box. So wait, then the box will be like this. There is a hole at here. Okay. Then after that, inside we got an alpha particle. Inside here we got alpha particle. Okay, this box is made by lead. Okay. Why lead? Because lead can block the radiation. For alpha, beta, and gamma, lead can block all the radiation. Okay. So we only need the radiation come out from these small holes. Okay. So inside this particle is called alpha particle. And we understand that in year 11, we did learning about this. Alpha particle is positive charge. It is positive charge particle. Okay, here. Then after that, we let the alpha particle shoot, okay? This yellow color, this is gold foil, thin gold foil. Why is using gold foil? Actually, gold foil can make very, very thin until only one layer of atom like this, okay? Because of this material, it can make as thin as possible, only one layer of atom, so we can see the effect lah, okay? Then after that, so alpha particle are the nucleus of helium atom and are positively charged. Yes, this is a positively charged. So we will observe three experiment result observations. From these three observations, we will make some conclusion. Okay, conclusion. Okay, so here we're having a look of a video here. Okay, wait for a show. Okay.
At the time he carried out the experiment, the atom was thought to be a blob of positive charge with negative electrons embedded inside it. Now Rutherford set up an experiment to direct a beam of alpha particles, which he knew to be heavy positively charged particles, and we now know to be the nuclei of helium atoms, through a very thin gold foil. The brass can in the centre of the picture contains a small americium-241 source producing alpha particles. Most of the particles are absorbed in the brass. There is a small opening producing a beam of alpha particles. They pass through a gold foil, which is about 1.5 microns in thickness, and they are then detected by one of the two detectors set up behind the foil. One of the detectors counts particles going straight ahead, which is the majority, and we count a rate of between 1 and 2,000 per second. The second counter, we can move to measure the scattering rate as a function of angle. Now, the experiment that he and his colleagues carried out was very laborious. It involved them sitting for hours in a dark room, holding a tiny fluorescent screen and looking just by eye for flashes of light on the screen. We've replicated that with modern detector technology. In its current position behind the foil, it will measure one count every few seconds. As Rutherford deduced, most of the gold atom's empty space, so the alpha particle just goes straight through, doesn't see anything, and goes through in a straight line. Occasionally, one of the particles will come close enough to the nucleus of the gold atom that it will be deflected by the electric field from the positive nucleus. If it comes at a glancing blow, it will be deflected through a small angle. If it hits it head on, it will just bounce straight back. And it's fascinating, I think, to them that this was This was telling us something very important that we didn't know about the very deep structure of matter. It showed that the atom had a heavy nucleus with mostly empty space with electrons distributed around it, which is exactly the picture we now have. It was also the start of particle physics. What Rutherford was doing, and what we're doing here, is taking a beam of particles, firing it at a target, looking at the way the particles are scattered, and from that deducing what was going on inside the target. And 100 years ahead, we now have the Large Hadron Collider, where we do the same thing. We fire a beam of particles at a target. In that case, the target is another beam coming the other way. We look for the particles being scattered out of that collision process and try to deduce what was going on in the collision from the behaviour of the scattered particles. And all that comes from Rutherford's original idea of firing a beam at a target. So in a century, we've come from an apparatus that would fit on the desk, that was at the cutting edge of physics, to the Large Hadron Collider, which is 27 kilometres in circumference. What was happening was that the alpha particles were going through and missing the nucleus, because the nucleus is extremely small and the atom, by comparison, is very big. So it's almost all empty space. And we had to wait a long time before one of those alpha particles hit the nucleus almost head on and bounce back into our detector.
Okay, boys and girls, basically we will have three observations. Okay, just now, did you observe that actually all the set they are very close to each others? Do you still remember what is the properties for alpha particle? Why they need to arrange everything so close? Okay, one of the properties about the alpha particle is alpha particle actually only can travel few cm, only few cm in the A. Okay, in the air or what, okay, vacuum, okay, only few cm. Why? Is because alpha particle is a very high ionizing, okay, the power for ionizing power is very high. Why? Ionizing is when it collide with the molecule, a particle, then it will lose energy. It will ionize the particle. The particle will become positive and negative ion. So when every time it collide, then it will lose some energy. So at the end, it only can travel few cm for alpha particle. That's why just now, if you observe the video showing all the set is very close, only few cm only. Okay. Then what else? Okay, we have three observations. The first one is we found out that there is most of the alpha particle, they just go straight. Okay, they just go straight without bending, without deflect. Okay, without deflect. So at here we can make a conclusion. The atom is mainly empty space. Okay, so it might be like this atom. Okay, then the nucleus is like this only. So most of the space like this actually is just empty space. So you imagine if the space is empty, so you can just run straight, okay, without colliding anything. So something like this, it will just go straight. It will just go straight. Okay, then this is the observations. The atom is mainly empty space for the observation that most of the alpha particle go straight without changing the direction. Okay, so here the nucleus, size of nucleus is very small. So my diagram here showing this is my nucleus. This is the whole atom. Okay, so the nucleus is very small. Most of the time it's just empty, then go straight. Okay, second observations, they found out that some of the alpha particle deflect at small angle. Small angle, this is the B here, small angle, it will deflect. Okay, deflection happen. Why deflection happen? It must be same type of charge. Okay, the nucleus at here, when it nears to it, it will deflect. It's because the nucleus here, we're having same type of charge as our alpha particle. So just now I did mention alpha particle is positively charged. So at here, the particle, alpha particle at here, near to the nucleus, something like this, near to the nucleus, so it will deflect. So this is our observation B. Okay, it will deflect. Okay, here we make a conclusion. There is a positively nucleus at the center. Okay, two positively charged, same charge as the alpha particles, they will repel. So deflect actually is repel. Okay, Then what else? Okay, from here we cannot know about neutron. Okay, we can know that inside is positively charged, it is proton, but I cannot know that inside the nucleus there is neutron. Okay, some of the tricky question they might be asking you that in the one of the option maybe is like nucleus contains the proton and neutron, but we cannot know neutron from here. Okay, this experiment we cannot know. Okay, see, third as observation is very small amounts or very a few only alpha particle they will deflect at large angle. At here the large angle means that it's greater than 90 degree. So it's greater than 90 degree. Okay. Then this one it will hit exactly on the nucleus and then it will rebound. So it will be something like this, hit it. Okay, then rebound. So this is the third observation C. Okay, so for this observation, what conclusion we can make for this? Okay, we can know that the nucleus is charged. Okay, we can know it's charged, so it will deflect. Okay, deflect, so I know that it's got charge. Then the mass is concentrated in nucleus. So most of the mass actually concentrated at the nucleus here. So you imagine if you run, suddenly you hit a fat boy. Okay, then you are the one fall down. It's not the fat boy. The fat boy is still standing there. Okay, so this is something like that. The alpha come here and hit on the nucleus. It will rebound backward. So at here in the atom, most of the mass actually is concentrated at the nucleus here. So mass is concentrated in nucleus. Okay, although the nucleus is so small, but the mass is the whole part. Mass is concentrated at here. Okay, so outside here actually we got electron, but the electron mass is very small lah. So inside here nucleus we understand inside got proton and neutron. Proton and neutron their mass is the same, then they are much more heavier than the electron. Electron is very small mass. Okay, so for this one we goes to your page number 2. Okay, here for this part 1 2 here hints at here actually is common question asking by students. So I did some survey, okay, to understand about this part. So you no need to memorize, dear. So far, the past year question, they didn't asking about this, okay. So the electrons surrounding the nucleus do not deflect the path of the alpha particle for the following reason. Okay, there is electron what? Right, surrounding it. Okay, but it doesn't affect the alpha particle. Why? Because their negatively charge is spread out throughout the atom. Okay, spread out throughout the atoms, and then alpha particle, the mass is big. Okay, mass of alpha particle is big. Mass is bigger than the electron and so on. Okay, because we got two proton, alpha, yeah, two proton, two neutron. Okay, mass greater, then inertia will be greater. Inertia, what is inertia? Newton's first law. Newton's first law said that object at rest, it will keep on at rest. Object moving in a straight line, it will continue moving in a straight line at constant speed. So since the alpha moving forward, it will continue move forward because of its inertia. Okay? Although there is electron, you might be asking, teacher, why electron doesn't affect it? How it move? Okay, electron. Okay, so this is two reasons, because the electron actually spread out all the atom, okay, throughout the atom. Then because alpha particle have a larger inertia, so when it moves, it will trying to continue move forward. Okay, another questions that will asked by student is why we choose alpha particle in the experiment? Why not beta? Okay, beta at here we are not using is because beta actually has a range of energy. They got energy is in continuous range, can be any value. Okay, continuous. This one we will learn in next worksheet. Okay, we'll learn about this. Next worksheet we'll talk about this. It's a continuous kinetic energy. So if for alpha, if we're using alpha, different energy, they will have different degree of deflection. So the result very difficult to interpret. Okay. Then for alpha actually is discrete energy. Okay, discrete. That means that it will be a fixed value lah. Okay, fixed value. So beta particle deflected by the electron, because beta particle is electron, it will be deflected by the electron also. Okay, beta particle is light, charged particle, they will interact strongly with electron, so they will be affected by the electron. Just now alpha doesn't, okay? Not just the nucleus, but also electron will be affected by the beta. Okay, as a result, most deflection occurs due to the electron and the electron interaction rather than interaction with the nucleus. Okay, so this is not what we want. Okay, then after that, one more reason is alpha have a very small mass. They will be easily deflected, lose energy quickly, and they do not follow well-defined path. Okay, so this one is knowledge lah. Okay, extra knowledge for us to know that why we using alpha, why not beta. Okay, then here, this is the structures of the atom as determined by the alpha particle experiment. Okay, so at here atom, we will have a positive small and positive nucleus. Okay, surrounding we got the electrons. The atom is actually around 100,000 times larger than the nucleus. So the nucleus actually is very, very small. But most of the mass actually is concentrated at here. Okay, then we go to your page number 3. Okay, before we start with the past year question, any question you want to ask should be fine, right? Actually, this we learned this before that. Okay. Doing Prasang asked, do we need to know about it have high ionizing energy? Actually, that expected you know. Because we did learning about this in your year 11 what? Okay, the properties of the alpha, beta, and gamma, we should know. We should know. Okay, that is our knowledge. Okay, there we go to your next page, page number 3. Okay, this is question 2022. When alpha particles are directed at gold leaf, number 1, almost all alpha particles pass through without deflection. Then number 2, a few alpha particles are divided through large angle. What are the reasons for this effect? Okay, dear, 20 seconds now. Okay, can you try? Then you type your answer and let me know. Read it A, B, C, D. Read all the questions. Then read all the answer. Then after that, you choose. Jore, yes. Jore, yes. Bashini, yes. Sean, no. Sean, read again and then try to choose another answer. Any others? Fatima, yes. Okay. So boys and girls, for this without deflection, so this one is go straight lah, meaning that go straight. If go straight what is the conclusion? It means that most of the space is empty. Okay, next. This one divided by through a large angle. This one large angle meaning that greater than 90 degree. So this one actually is hit and rebound. Rebound. The case of rebounds. Okay, when rebound, that is the third observations. Third observation saying that the nucleus actually is very small, and then it hit on the nucleus. Most of the mass actually concentrated at the nucleus. So as I told you, the fat man standing there, you running and towards hit the fat man. So you are the one fall down, not the man. Okay. Then Chonghan answer correct. So boys and girls, your answer for this question should be C. Okay. Why go straight? Because nucleus is very small. So alpha particle miss the nucleus. Nuclei is the plural of nucleus. So at the center there, okay? Most of the alpha particle, they go straight, they without meet with the nucleus, okay? Then greater than 90 degree, this one is hit and rebound. So this one is the path of the alpha particle is close to the nucleus, okay? It's very close to nucleus and then hit and rebound, deflect back. Okay, we go to your question number 2. What a conclusion from the alpha particle scattering experiment. What is the conclusion? A, B, C, D. Okay, Fatima, correct. Jore, yes. Vashini, yes. Any others? Kai Qian, Sean, Sean, no. Sean, this one just now I did mention. Choose another answer. Your answer is wrong. Just now I did mention. Manjo, yes. Okay, dear, here the answer at here should be C. This is the conclusion that we can make. Okay, Sean, correct. Okay, dear Sean, why just now the answer is wrong? I didn't mention this one. From this experiment, we can't know about neutron. Okay, we cannot make a conclusion that nucleus contains neutron. No, we cannot. Okay, then the A, proton and neutron have equal and opposite charge. How we know? We don't know. From the experiment, we don't know. Okay, we only know three. Okay, most of the space is empty. Then the nucleus contains the positively charged, which is the proton. Then number three is the most of the mass is concentrated at the nucleus. Okay, so B also cannot. We cannot know. Proton is much larger mass than the electron. Okay, here statement A, B, C. Their statement no problem. Their statement is correct, but they are not the conclusion that we can make from the alpha particle experiment. Okay, their statement no problem, the sentence no problem, the information no problem, but that is not the answer. Okay, for the conclusion from the experiment. Okay, number three. In an experiment on alpha particle scattering, alpha particles are directed at a thin gold foil. Most of the alpha particles just go straight or are deflected by small angle. A small number of alpha particles are deflected by a large angle. Which statement cannot deduce from the experiment? A, B, C, D seems like correct, right? Jore correct. Chonghan correct. Fatima, no, try again. Manjo, yes. Washini, yes. Okay, so cannot. Read the question carefully. So this one, empty space, yes. Most of the space mass is concentrated in nucleus, yes. The nucleus contains proton. Actually, from the experiment, we only know that it have a positively charged at the nucleus. Positively charged at the nucleus. Okay? So proton or non-proton, actually, we don't know. We just know that nucleus is positively charged. Okay, the nucleus of the atom is very small compared to the size of atom, yes. So this is size of atom, this is the nucleus. It's very small, yes. So answer C. We can know that it deflected. It's because the nucleus having same type of charge as alpha, which is the positively charged. Okay, so we go to your page number 4. Is it okay until now? Press the reaction button. Yes, Fatima, okay. Kai Chen, okay. Vashini, Wanjo, okay, dear. We go to the next question. There is two alpha particles with the same kinetic energy are moving towards and are then deflected by a gold nucleus. Which diagram could show the path of the two alpha particles? A, B, C, D. Think which one is correct path. Manjo, yes. Fatima, yes. Washini, yes. Chonghan, Jore, Sean. Chonghan, no. Chonghan, no. Jore, Sean, Prasan. Jore say gua. So wrong, no? Not gua. Sean, no. Chonghan, no. Prasan, no. Kai Qian, yes. Okay, dear, the correct answer, Sean, let me have a look, Sean. Yes, Sean, correct right now. Okay, dear, correct answer should be donkey. Why? Okay, can you see that? How it deflected like this, eh? It going to, if they hit, it will be bounced back like this. Or it hit, bounce back like this. It won't be go here and then attracted. Is it this one is attracted? No, okay. Prasan correct. Okay. So this one, it will bend like this. This part is confirmed wrong. It won't be bent, attracted, and then go back. No, no such thing. Okay, so then we only choose from B and D. B or D. Okay, you see, this line, it is nearer to the nucleus, but it's just showing a small deflection, small angle deflection. But then, this path is further away, far away from the nucleus, but it's showing a larger, but not 90 degree, not more than 90 degree lah. At least we compare these two, is larger angle deflection. When you further away, how can you larger? When you further away from the same type of charge, you should deflect with a smaller angle. So our answer for D is correct. You see, this one is near to the nucleus, so it will deflect either is greater angle like this, either like this, greater angle, but it won't, okay, it's something like this, bigger, sorry, like this, okay. Then this one will be slightly smaller angle. This one okay, like this also okay. Okay, it will deflect with a bigger angle, and then further away, the path it should be smaller angle deflection. But you don't draw straight line, you don't draw straight line. Okay, if let's say this one they draw like this, asking you, hey, second path, how was your path? So it's slightly further away. We expect you like this. Okay, deflect with a smaller angle. If you draw a straight line, they can deduct your mark. It won't be like a larger angle deflection when near to the nucleus, then another one slightly further away, then you go to straight. No, we expect you have a slightly smaller angle deflection. Okay, for D at here, either is we deflect like this with larger angle, or we assume that it's very close to the nucleus, so it hit and rebound. Hit and rebound. So this one is greater than 90 degree lah, the deflection. Okay, then this path is not a straight line. It will have a smaller angle compared to just now, the first path of the alpha particle. So our answer should be donkey. Okay, I repeat, no such thing, go here, attracted back. No, no. A and C confirm wrong. Then B is the problem is nearer to the nucleus. It should have a greater deflection. But this B is wrong is because further away, why it got a greater deflection. So this one is wrong. Answer is donkey. Okay, is that clear? Because this question, a lot of you answer wrongly. So is that clear for this part? Is that clear for this part? This question? Kai-Chen okay, Okay, Vashini, okay. Those just now answer wrongly, so okay, Okay, Chonghan, okay. My dear, number 5, this is 2021 past year question. When alpha particles are fired at a thin metal foil, most of the particles go straight. Is it this one? Oh, no. It's a new question. Okay, pass straight through, but a few are deflected by a larger angle. Which change would increase the proportion of alpha particle deflected by a larger angle? This question is a very good question. I need you to think and then tell me your answer. How you change and you can increase the proportions of alpha particle? Sean, correct. Sean, you did this question before. Jore, correct. Chonghan, correct. Hey, not bad. Fatima, no, can try again. Washini, Manjo, Vashini, yes. Vashini, yes. Oh, this question, okay. Okay, good job. Manjo, no. Because a lot of my students, they can't answer for this question. Okay, but so far at here, you guys are not bad lah. Most of you can answer it. Okay, dear. We want to increase the proportion of alpha particle deflected by large angle. Okay, what is the method? Prasan correct. Okay, boys and girls, if A, you choose alpha particle with greater kinetic energy. Greater kinetic energy means what? It will move faster. Okay, it will move faster. If move faster, will it easily deflected? My answer is no. if move faster, it will be deflected less. Okay, deflected less. Okay, deflected less. Okay, then B, using a double thickness of foil. If you're using double thickness of foil, what does it mean? Meaning that you have more nuclei are encountered by the alpha particle. Okay, double thickness of foil, so you got more nucleus. So the chance for the alpha particle to hit on the nucleus, it will become higher chance. Okay, higher chance. So you will get a higher proportions that the alpha particle deflected by large angle. Okay, so it get higher chance. So answer should be B. Answer should be B. Okay, C, using a foil made of a metal with a fewer proton in its nuclei. Okay, if like this, that means that you will decrease the proportion. Okay, decrease the proportion. The chance to hit on the nucleus is lesser because only few proton. Okay, in its nuclei. Okay, it deflect is because the alpha particle close to the nucleus. Okay, close to the nucleus. So if you are only a few protons inside the nucleus, you will decrease the proportion for the alpha particle to hit it. Okay, then this one D, using a source emitting more alpha particle per unit time. Seems like this one is okay, right? We're having more alpha particle per time, but actually at here, this will just increase the number detected but not the proportion. Okay, so at here, this will increase the number detected but not the proportion deflected. Okay, it doesn't increase the proportion, but B is the correct answer. For this kind of question, actually ask for few times lah. Okay, ask for a few times. I saw this kind of question like at least 2 to 3 times at least. Okay, boys and girls, is it okay for this part? Can we go to the page number 5? Okay, Kai Chen, okay, Fatima, okay, Vashini, okay, Chonghan, okay. So let's go here. Okay, number 6. A beam of alpha particle is incident on a thin gold foil. One alpha particle collides head-on with a gold nucleus and deflected back along its original path. Okay, which statement could explain why recoil speed of gold nucleus is more compared to the recoil speed of the alpha particle? So 20 seconds, read it, think it, and then give me the answer. Fatima, no, think again. Jore, yes. Jore, yes. Vashini, yes. Sean, yes. Any others? Why the recoil speed is more? Fatima, yes, right now. Manjo, no. Chonghan, yes. Okay, dear, collide head on. Collision. Collision, we must obey what? Momentum. Momentum, conservation of momentum. Momentum is conserved. Okay, so what does it mean? Okay, after that they will recoil backwards. Okay, it will recoil backwards. So at here the momentum Kai Qian, no. Okay, you will know that, let's say this is the nucleus, so this is the alpha. Okay, when they hit and they will rebound. Okay, here the mass times the velocity, and this one mass times the velocity. I say 1 and 1 and 2 and 2 lah. Okay, can you see that the answer should be C? Answer should be C. Okay, can you see that this is nucleus? Okay, this is alpha. Nucleus, they will have a greater mass. Okay, the nucleus, the mass is much more greater. So the speed at here, the mass, this one mass is higher mass. Okay, then this one is lower. It must be lower. Because you can imagine maybe a fat man runs slower, something like that. Okay. Then this one the mass is small, then the speed will be higher. Okay, so for this answer, why the recoil speed of the gold nucleus is more? Because of the mass. Okay, the mass of the nucleus is greater, so the speed will be slower. Okay, A answer, most alpha particles are only slightly deflected as they pass through the gold foil. Most alpha particles are only slightly deflected. Okay, yes, when they pass through the gold foil. This statement is a general observations, no problem, but this is not the reason why the recoil speed is more. Okay, it doesn't explain about this. Okay, then B, the alpha particle and gold nucleus repel each others. This one is just showing that they got replaced a deflection. Why deflection happen? Why there is deflection happen? So this sentence is only explained about this. Also not explaining about why the speed is smaller for the nucleus. Okay. Then the last one, momentum of the alpha particle decrease as it approach the gold nucleus. This one also doesn't explain why small recoil speed. Okay, the momentum will change direction, but it doesn't change. It doesn't explain. Doesn't explain. So the answer is actually C. Why smaller speeds is because the mass is larger. Okay. So we goes to question number 7. We goes to question number 7. Okay, one of the result of alpha particle scattering experiment is that a very small minority of the alpha particle are scattered through angle larger than 90 degree. So this is greater than 90 degree is hit and rebound. Okay, state what may be inferred about the structure of the atom from this result. So this one 2 marks, you see 2 marks. So what is the answer? Okay, the answer is here. 2 marks is here. It will hit and deflected backward through a larger angle. So 2 marks. 1 mark is deflected. So I know that the nucleus got charge and then the charge is same as the alpha. Okay. Then second one is why it greater than 90 degree is a larger angle. A large angle is because the mass is concentrated in the nucleus. Okay, most of the mass actually at the nucleus. So when it hit it and then it will rebound. So this is the 2 answer here. Okay, we write together. Okay, 2 marks. So you always check the mark and then write the point for the according to the mark. Okay, so at here, scatter. So I know that nucleus is charged. Okay, this one. So I know that this. Okay, angle greater than 90 degree, I can know that the majority of the mass of atom is in the nucleus. Okay, so this is the 2 conclusion we can make, okay, from the observation, third observation. Greater than 90 degree, that is a very, very few alpha particle happen. Okay, when they are very close to the nucleus. Okay, 10 seconds for you to complete. Then one more question will go to the next part. Okay, if you're done, give me the response, then I can know that we can go to question number 8. Kai-Chen, okay. Fatima, okay. Dana, Fashini, okay. Chonghan, okay. Okay, dear here. The result, this is 2021 past year question. The result of alpha particle scattering experiment provide evidence for the structure of the atom. Okay, most of the alpha particle go straight, okay, or divided by small angle. Then result 2 is a very small minority alpha particle is scattered through angle greater than 90 degree. Okay, so from the result 1, so what conclusion we can make? Very easy. Go straight is Most of the atom is empty space. Okay? Or you can say that the nucleus is very small compared to the atom. Okay? Or you can say that nucleus is very small compared to the atom. Therefore, most of them just go straight. Okay, most of them is just go straight without divided, or if they really divided, also small angle. And some of them okay, some of them will be divided by small angle. But for the greater angle greater than 90 degree, this is only a few alpha particle. So this one is 2 marks. Okay, basically the answer is here. Okay, the nucleus is charged. The majority of the mass is actually in the nucleus, or we say that the mass is concentrated in nucleus. Okay, or we say that the mass is concentrated in nucleus. 2 mark, then we give one more point. The nucleus is charged. Okay. Okay, done. 10 seconds for you to complete. Okay, done? Yes, sir. Okay, let's go for the next part. Atomic structure. The atoms of all elements are made of 3 types of particle: proton, neutron, and electron. Okay, for proton here, the charge is positive 1e. Electron is negative e. Neutron is 0 charge. It's neutral. Okay, year 11 we also learn about this, right? We also learn that proton is positive E, electron negative E. But why it is positive E? Why not 2E? Okay, this one in the last worksheet of this chapter, we need to learn about the quarks. The structure, the structure, something like structure inside the proton. Okay, we will learn about that, and then we will try to do some calculation. At the end, we will find out that, proton actually is positive E. Okay, the charge is positive E. So this one we will learn. Okay, the mass, just now I told you, the mass for the proton and neutron actually is the same. So at here, we can say that they are 1U, okay, in unit of U. So this one also 1U. But electron is very, very small mass compared to proton and neutron. So it is 1 over 1840 U. So can you see that it's very, very small? Let me calculate the decimal. 1 divided by 40. Okay, it was like 0.0005 U. Yes, 1, 2, 3, 4. Okay, can you see that? When proton is 1, neutron is 1, this is 0.0005 U. So that's why, you see, in the atom, most of the mass actually is here. It's come from the proton and neutron. The electron at here, actually, they are almost negligible, the mass, very, very small, okay? So here, where we can find the proton? In the nucleus. In the nucleus. Where we can find the neutron? In the nucleus also. Where we can find the electron? Orbit. Okay, orbiting around nucleus in shells. Okay, 10 seconds for you to complete. Okay, positive E. E is the charge. Okay, so it is 1.6 times 10 power of negative 19 C is a charge. Okay, mass at here, because mass we know most of the time in physics we say that gram, kg, am I right? But do you know that the atom so small? The atom so small. We're using that I cannot see. So impossible we're using kg and gram to to give the unit as the unit for it. Okay, the kg and the gram are actually two big unit for it to describe the mass of the atom. So at the end, the scientists they come out with the unit called atomic mass unit. Okay, U. So U. So at here 1U. 1U equals to how many kg? 1U equals to 1.66 times 10 power negative 27 kg. Do we need to remember? Actually, at the past year paper, your exam paper and S paper, page number 2, they will have the data. One of the part, actually, you can find this value from there. Okay, no need memorize also, never mind. This one E also the same. Okay, but when we do more and more practice, actually it will be in our brain lah. It's okay. So at here 1U is this. You see 1.66 times 10 power of negative 27. So can you imagine how small of the mass for the proton, neutron, and some more electron? Okay. So next, the mass of the atom in AMU is in if you are studying SPM, we might using AMU lah, but actually it's the same lah. Okay, or sometimes we just say U. Okay, the mass of the atom in U is roughly equal to the sum of its protons and neutrons. Okay, mass equals to nucleon number. Okay, mass is equals to the nucleon, almost, okay, almost roughly equal. So the mass is nucleon number. So you see that this is nucleon. So the mass will be 235U. Okay. The next, proton and neutron, they are held together by strong nuclear force, okay, to overcome the electrostatic repulsion between the proton. Proton and proton, they are same type of charge, what? They will repel, what? So why they still can stay together is because in between them, there is strong nuclear force. Okay. Until here, is that clear? Can we proceed to the next page? Okay, so it goes to the next page at here. This one actually is easy. You already know about this. This is a nuclide notation. Okay, so this part is the element, symbol of the element. So, for example, lithium, okay, potassium, calcium, okay. So we'll write at here calcium Ca. Okay, then A at here is called neutron number. A nucleon number actually is proton plus neutrons. Proton plus neutron. Okay, then the Z at here is called proton number. If this is what we say, if the question say atoms, once you saw the keyword of atoms, once you saw the keyword of atoms, we understand this one is in neutral. If it is not neutral, we will say this is ion. Okay, ion, instead of we say atoms. So when you saw the keyword of atom, it must be neutral. If it must be neutral, then number of electron, it must be equal to number of proton. Okay, so at here, neutron plus proton actually called nucleons. Okay, how we find the number of neutron? You using nucleon number minus proton number, that is the neutron number. I believe that you know this because in year 11 we did learn about this. Chemistry we also learning. Okay, so we can go down. Isotope also, we learned this before. Okay, all elements have isotope. Isotope have identical chemical properties. Okay, why? Isotope, they will have, you see, they will have equal number of protons. So isotope will have equal number of protons. Just now I did tell you that atom is neutral. So equal number of proton, that means that equal number of electron also, right? Okay. So how you affecting your chemical? The chemical properties is depends on the number of electrons. So if you are same group, this one is chemistry already, same group. Okay, same group, then it will having the same chemical properties. Then how I know that is same group? Okay, the number of the outer cell most electron. Okay, the outermost cell electron, number of the electron at the outermost cell, if they are the same, then they are belongs to the same group. Okay, chemistry I'm not really sure lah. Let me think. Lithium, sodium, potassium, is it lithium? Sodium is Na, I think. Potassium is K. I think. Okay, lithium, is it 2 1, dear? Is it 2 8 1? Is it 2 8 8 1? Somebody can answer me. This is chemistry. Is it correct? What I write? I want to make sure correct. If not, I talking something wrong. This is chemistry, Washini. Yes, correct. Okay, dear, you see, this one, the outermost cell is 1 electron, 1 electron, and 1 electron. If they are same group, then they will having the same chemical reaction, right? Okay, so this one, like group 1, what is their chemical properties, their boiling point, melting point, and so on. Okay, they are same group, they come from the group number 1, so they were having the same chemical properties. So why we say that isotope also having same identical properties is because they're having same number of proton, therefore they were having same number of electrons. So can you see that this example, how many proton at here? I got 1 proton, 1 proton, 1 proton. That means that I got 1 electron, 1 electron, and 1 electron. Since they are having same number of outer cell electron, number of electron is the same, so their chemical is the same. Chemical properties will be the same. Okay, so this part, why isotope having same identical chemical properties is because of their electron, same number of electron. But of course, isotope definition, what is the mean of isotope? You don't tell me that the element that having the same number of electron. Although your statement correct, but this is not the definition for isotope. You must tell me that isotope is the element that has equal number of proton but different number of neutron. Okay, here if I change to nucleon, no problem. Okay, neutron or nucleon, no problem, because nucleon is proton plus neutron. Okay, so can you see that these three actually they are isotope because they're having same number of proton. Okay, since isotope have imbalance of neutron and proton, they become unstable. If they stable most of the time, if they stable is because the proton and neutron number, they are almost the same or they are the same. If we got too much of the neutron, then the isotope will become unstable. If they unstable, they will start to decay and they will emit some radiation to let itself to become a stable. So this one is worksheet number 49. We learn about decay. Why they decay? Because unstable. So they were trying to do something to make themselves stable. Okay, so we go to the partial question, page number 8. Is it okay? Can we proceed to the page number 8? Okay, let's go. Okay, dear, come here. What are the isotope? Easy. Chonghan, no. Chonghan, no. Wait. Chonghan, no. Fatima, yes. Washini, yes. Kaichen, yes. Chonghan, yes, right now. Jore, yes. Chonghan, just now you give me the wrong answer. I thought my answer is wrong. Parsan, correct. You read too fast. Yes, dear. Okay. Answer should be C. Okay, dear, they are same element. Can you see that at here? I come back to here. You see element, hydrogen. Then this one H, symbol H. They are same element. Okay. Then different number of neutron. So this one should be same number of proton. Then this one different element. So we just cancel. Okay. Then we go to question number 2. Can you tell me A, B, C, D, which one is the isotope of Q? Jore, yes. Kaichen, yes. Vashini, yes. Vashini, did I mark A? No. Fatima, yes. Sean, yes. Okay, dear, A. Okay, here, highlight X. This one also X, proton. We refer to the proton number. Chonghan, yes. Okay, dear. Let's go to the question number 3. Two nuclei are different isotopes of the same element. Okay, they are isotopes. Which statement about the nuclei is correct? They are isotopes of the same element. Fatima, no, read again. Read again. Washini, yes. How about others? Fatima, yes. Jory, yes. Chonghan, yes. Sean, yes. Kaichin, yes. Okay, dear. Answer A. Okay. Uh, neutral atom with the same number of electrons. Okay, same element, then isotope, that means that same number of proton. Then at the same time, it means that same number of electrons. Okay, different number of protons, so this one is wrong. Same number of neutron, no, because they will have different, this one isotope will have different neutron. So C is wrong. Same number of neutron, no, it should be different. Okay, goes to question number 4. Each option shows the number of neutron, proton, and electron in 2 atoms. Oh, okay, we got 2 atoms. Here one, here one. Okay, some of which are ionized. Which pair of atoms in the table are isotope of the same element? Washini, yes. Sean, yes. Chonghan, yes. Easy. Jore, yes. Okay, here again. Isotope. No matter how, look at the proton. Okay, look at the proton. As long as the same proton number. So isotope, same number of protons. So protons here, 17 and 19, no. 23 and 24, no. 29 and 29, yes. Answer is C. Okay. Then why, teacher, you said that the electron must be the same as the number of proton? What? Why this answer C is correct? Dear, some of which are ionized. Okay, so it might lose electron or it might gain electron. Ionize is meaning lose or gain electron. So dear listener, in the atom, only electron can be lose or gain. Proton all the time will be there because just now we got mentioned it hold by a strong nuclear force, right? So if ionize meaning that lose or gain electron. So at here they are different. No problem. Meaning that this one another atom lose electron. So it become ionized. So C is correct. But when we say atom, it is neutral. But here they told you that some of the atoms are ionized, meaning that they no longer become atom, they ionize. So ionize is positive or negative. If positive means that we lose electron. If negative, that means we gain more electron. Only electron can move in and out. Okay, gain or lose. Proton cannot because proton and neutron they stay inside the nucleus. They hold strongly by the nucleus, strong force. Okay, strong force holding them together. Okay, can we go to your page number 9? Okay, let's go here. Okay, the table contains data for 4 different nuclei P, Q, R, S. Which 2 nuclei are isotope of the same element? Try. What, Jory, so fast? Yes, correct, Jory. Washini, yes. Kaichin, yes. Sean, yes. Fatima, yes. Who else haven't answered me? Chonghan? Chonghan, no. Chonghan, try again. Manjo, yes. Okay, dear. Chonghan, let me have a look. Chonghan, yes, correct. Okay, dear, here. Isotope, look at the number of proton. But here the table doesn't have proton, teacher. So you have to think how you are going to find the proton. Okay, proton number. Okay, here, this one nucleon is proton plus neutron. This is neutron. So how you going to find the proton? Okay, so you should using proton plus neutron minus this neutron number. So after you minus 10 minus 5, this is 5. 10 minus 6, this is 4. 14 minus 6, this is 8. 16 minus 8, this is 8. So your answer, which one are isotope? Look at the proton number, these two. R and S. R and S. Okay, donkey. Okay, so you need to do some calculation. Okay, question number 6. This one settle. I move down. Okay, here. Can you try again? Which two nuclei are isotope to each others? John, yes. Fatima, yes. Vashini, yes. Chonghan, yes. Jore, yes. Manjo, have you done? Okay, this is proton plus neutron plus electron. Nucleon is proton plus neutron. Okay, here from these two, proton, proton, neutron, neutron, that means that we minus, we can get the electron. Okay, so whatever, we find the electron first. Number of electrons. Okay, so at here, if you find the electron, this one should be 11, 12, 11, and 9. Okay, teacher, this is electron. I still don't know about the proton. Yes, you can know, dear. Why? Highlight neutral atom. Neutral atom means number of electron equals to number of proton. So at here, this one is also equals to the protons. So which one are isotope? 11 and 11. So W and Y. So answer should be B. Okay? Answer should be B. Is that clear, dear? Okay, then we go to the last question for this worksheet. Okay, here, dear, there is a list, table list, the nucleon number and proton number. The nuclei are represented by the letter L to T. Oh, so many. Which row in the following table correctly show three nuclei of the same element? Three nuclei that have to have the same number of neutrons. Okay, count. I didn't count. I need to count by myself. Okay, Fatima, yes. Fatima, yes. Let me count. I also need to count. Okay, let me check your answer. Jore, yes. Chonghan, yes. Vashini, yes. Sean, yes. Manjo, have you done, Manjo? Okay, here. Same element. Same elements, meaning that isotope lah. Okay, isotope. Same number of the protons. Same number of protons. So we look at this. Okay, proton number, it should be here. This is one pair. Okay, LMN, correct? LMN is correct. Then after that, this must be another one pair. OPQ, so OPQ, correct? Then last pair is here, 91, 91, 91. This one is RST. No RST. Okay, so that means that from here, our answer should be A or C lah. Okay, Manjo correct. Kai Qian correct. Okay, dear. Number of neutron, then you count lah. This one nucleon minus proton, so you get number of the neutron. Okay, neutron number. So I did count. This one is 138. This is 137, 136. Then after that, this part is 137, 136, then 135. Okay, then here this is 136, 135, 134. Okay, A RPN. RPN. Here R. R is here. That means this one. P is here. That means this one. N is here. That means this one. Is it correct? Yes. You see? 136, 136, 136. They're having all the same neutron. Answer should be A. Okay, C, is it correct? We have a look first. M here. M, where is it? M here. So this one, M. Then P. P is here. P is here. So confirm wrong. These two is not the same. Okay, so C is wrong at here. Okay. So this part is still considered very easy, right? I told you chapter 11 is for me is the easiest chapter in our AS. Okay, until here any question? If no question, we are going to the worksheet 49. Aichen okay. Fatima okay. Vashini okay. Chonghan Yore okay. Sean okay. Manjo okay. Manjo okay. Okay, then boys and girls, we go to the worksheet 49. We will learn about four type of radiation. Okay, four types. So just now Prasan asking, do we need to know the alpha, beta, and gamma? Actually, they assume that you know about that. Okay. Not much question about passive question asking about the ionizing, the penetrating, what else? Roughly like this. How fast is moving? Not much question about this. Okay, not much question about this. But in the roughly like very old 2013 and below or what older than that, they did asking about this question but not much. The main idea keyword that they want to test on you actually is something new at here. Beta. In our year 11 we learned about beta decay. We don't know that actually beta got minus, beta got plus, but right now in AS actually beta that we learned in year 11, that is beta minus. So actually, not only beta minus, we still got beta plus. So this is something new. Beta plus is something new in our AS. Okay. So most of the times they want to test on you, they are testing on these two part lah. Instead of they asking you ionizing, penetrating, but they might be asking you because they assume that you know about this. Okay, just now we did say that some of the nuclei they are unstable. It might be like we got extra neutron. Okay, extra neutron. So therefore they are unstable. So when they're unstable, they try to decay. Okay, they try to decay and emit radiation. So this one is called radioactive decay. We will have four types of decay. In year 11, we say alpha, beta, and gamma. But right now, add one more, beta plus. Year 11, what we learn about beta, actually we're talking about beta minus. That is what we already know. Okay, so alpha is 2 proton, 2 neutron. Alpha is the helium nucleus. 2 proton, 2 neutron. Okay, just now we said that 1 proton is 1 U. 1 neutron is 1 U, right? So at here, 2 proton, 2 neutron, how many mass in terms of U? My answer is 4U. Because 2 proton, that means 2U. 2 neutron, another 2U. So it's 4U. Okay, what is the charge? Neutron, no charge. Neutron is no charge. Just now we learned. Proton is 1E. Now, how many proton do you have? You got 2 protons. So it's plus 2E. We got 2E. Okay, so just now we said that the proton and neutron, they hold strongly. The force, nuclear force is actually strong force. Hold them together. If not, they will repel because positive and positive together, they're trying to repel. But why they still can be hold strongly at the nucleus is because the force that holding them, the nucleus force is strong to hold them together, force them together. Okay, beta minus. That is an electron. Okay, electron. So electron, just now we said that is 1 over 1840 U. If you press your calculator, you should get 0.0005 U, or 1 over 1840 U. It's very, very small mass. Okay, then the beta minus electron, the charge is negative E. Okay, negative E. What else? Oh, the force is weak. Therefore, the electron can be loose, can be gained. Okay, the force that holding the electron actually is weak force. Then beta plus is positron. It is a positron. What is this? You see, this is tron, is actually electron. Positive electron. Positron. Positive electron, we call it as positron. Okay, so this part is positive. This is electron. Positive electron is called positron. So can you see that just now electron is minus, this one is electron in positive. Okay, so what is the mass? The mass is the same, 0.0005. So if you refer to the just now worksheet is 1 over 1840 U. So it's roughly equals to 0.0005 U. Okay. So the charge, positron, positive one. So it should be positive E. Only one E. The force is in between is also weak force. Okay, this one important. They like to ask about this. Okay, the alpha, what is the force? Strong force. Describe the force for the beta minus beta plus is weak nuclear force. Okay, gamma. You don't tell me that gamma is a particle. Actually, we cannot say particle. Particle can describe these three. Okay, particle can describe these three, but alpha, you don't say particle. Alpha is a ray. It's not a particle. So we say gamma ray. If you can't remember, hey, which one, teacher? I can't remember. Okay, it's okay. Or you say alpha radiation, beta minus radiation, beta plus radiation, or gamma radiation. This one confirm correct. Okay, but if you want to write particle, you cannot write gamma particle. It's not a particle, it's a ray, or we say wave. Okay, the mass is almost negligible, 0. Then the charge is 0. Then the force is called electromagnetic force. Electromagnetic. Okay, just now U is the unit that we use to for the atom, because the atom is too small. Okay, the mass is too small. We cannot use kg and g, so we're using U. Okay, 1 U is represent 1.66 times 10 power negative 27 kg. E is the charge of electron, 1.6 times 10 power negative 19 C. All these are provided in the paper. Okay, they will be provided. You can go to the front page and then find it out. Okay, speed of light, c is 3 times 10 power of 8, because we understand gamma is a family member of electromagnetic wave. Still remember electromagnetic wave, EM wave. Okay, what is the 7 EM? I did teaching you one of the wave chapter. We learned about this one, right? So, Ramly burger, make Indian vegetable, unto ex-girlfriend. Okay, so we got 7 family. So gamma ray is one of these. Gamma ray. Okay, gamma ray is here. So how fast the EM wave they move? In the vacuum or in the air, almost the same, almost the same. So they are moving for these 7 family member, they're having same DNA, so they will have a lot of properties, same properties. So one of them is they're moving with the speed, same speed in the vacuum, which is 3 times 10 power of 8. Okay, then beta, you see beta is electron or positron. Their mass is very small, so they also consider quite fast, quite fast. But for the alpha, you will find out that the speed is actually quite slow. It's because of the mass. The mass is 4U. So you imagine very fat. How can it run very fast? Okay. So this is the part. Okay. Until here, is that clear? This one is just recall, and then we add on beta plus only. Okay? Fatima, okay? How about others? Mashini, okay? Kai Chen, okay? Okay, then we proceed. Antimetal. Okay, we live in the universe made up of metal. Metal is proton, neutron, electron, and so on. So all metal particles have their antimetal counterparts. Okay, at here, this one also important. Antimetal particle, they are identical to their metal, but they having opposite charge. They will have the same magnitude, but opposite charge. Okay, what does it mean? Okay, we look at here. Electron, what is the charge? Negative E, am I right? Negative E. So, their anti-metal called positron. So, it will also having a charge, same magnitude of charge. So, it's also E, but the charge is opposite direction. So just now it's negative, now it's become positive. Okay, proton, what is the charge? Positive E, 1 E. Antiproton, this is antimetal of the proton, so it will still E, but it will become negative, opposite charge. Neutron is zero charge. Of course, anti-neutron, we don't have charge, so it's still zero. Okay, is that clear? So positron actually is the antimatter of electron. Okay, we go to page number 2. They will have 4 most common type of radioactive decay. Okay, I put the alpha and gamma together first because this is something that we already know, nothing new. Okay, alpha particle are high energy particle made up of 2 proton and 2 neutron. Because of these 2 protons, so it's positive 2e lah. Okay, then they are usually emitted from nuclei that are too large. Okay, the neutron, we got too many neutron unstable, so they will decay. Okay, so at here, this one is the symbol of the alpha particle that we decay. So sometimes it might be writing helium also, no problem, doesn't matter. Okay, then you will find out that the new element, you see element is already changed. They are different element. So isotope is same element. Now decay, they will produce a different element. And the new element, you need to balance. So this one you already know, you need to balance. A minus 4 plus 4. So you get back A. Okay? So this is alpha. Gamma actually is high energy electromagnetic wave. Just now, we got mentioned about the gamma is actually no charge, no mass. So actually they also don't have the proton number and neutron number. For this our gamma, when they will emitting the gamma, is when this atom, maybe they still after decay, they still at high energy, so they're trying to make itself to stable, they can release some energy. So this one is they help the emitted, okay, they are emitted by nuclei that need to lose some energy. So after they having the gamma ray, so this one is high energy, high energy. This is called parent nuclei. Then this is called daughter. This one product called daughter. Then it will be have a low energy. When they emitted out the gamma ray, they will produce a product with a lower energy. Okay, they will lose some energy here. But the mass number, the neutron number, the atomic number, or we say proton number doesn't change. Okay, so this one all is just recap your knowledge. So the new thing is on the page number 3. Can we go to page number 3? Fatima, okay? Chonghan, okay? Okay, Manjo, okay. Something new is on page number 3. Washini, Kai-Chen, thank you. Okay, thank you for responding. So here see beta minus. Beta minus is actually electron emitted from the nucleus. Okay, beta minus is electron. So at here, from the nucleus, we found out that we have too many neutrons. We have too many neutrons. So from the neutron here, we will emit it out, and then we will have a proton plus an electrons. Okay, plus an electrons. So the electron, this electron we call it as beta minus. The electron is beta minus. Then this proton, where this proton going, teacher? The proton, you see, just now I told you, it hold by a strong nuclear force. So this one will just stay in nucleus. It will just stay. Okay, this is neutron. One neutron emitted out and it will split out into proton and electron. The electron is called beta minus. Then where is the proton going? Proton doesn't go anywhere, it still stay inside the nucleus. Okay, at here, one more particle in air level we found out, discover in air level, which is called, they will have third particle called antineutrino. The symbol is like this, VE, then upper part here draw a line. This is called antineutrino. Antineutrino. Antineutrino, it doesn't have energy, it doesn't have mass. Okay, it doesn't have mass, so it will be 0 0 here. Okay, this is called antineutrino. Why in it, when we have this antineutrino, this one will be explained in the end of this worksheet. Okay, we will explain why we got the particle. Okay, so neutron convert to the proton and emits one electron, which is a beta. This one we learned in year 11. Okay, so we have a proton, we will have an electron and anti-neutrino. So this one is just balance the equation. Okay, we balance the equation. How about beta plus? Okay, beta plus is they're having a is a high energy positron. Positive of electron in positive lah, something like this, antimatter of electron. Okay, why we got beta plus? It's because inside our nucleus we got too many proton. Just now is too many neutrons, so we decay to get a proton and electron. Now it's opposite, reverse. Okay, now at positron at here, why we got positron is because there is a proton, too many proton. The proton will decay and get neutron plus positron. So this one is positive. Positron. Then positron, same, we will have a third particle called neutrino. Just now called antineutrino. Now beta plus, the particle called neutrino. Okay, neutrino. So upper part no need a line. Okay, electron together with electron, antineutrino. Now together with beta plus, that is neutrino, no anti. Okay, so at here, boys and girls, you have to remember, when beta minus is actually what convert to what, you have to know. From neutron to proton, you have to know. Okay, beta plus, you have to know, is from proton to neutron. Okay, I will teach you how to memorize, dear. Beta plus. So positive lah. Positive. Beta plus is positive. Am I right? Plus is positive. So proton or P, you can think about like positive. So we start from proton. Start from proton. Beta plus plus. So we start from proton, goes to neutron. Then another case will be from neutron to proton. That's all. This is how I memorize. Okay. So using the some technique helping us to know lah. Okay. So at here, proton is transformed to neutron, positron, and neutrino. Okay, so basically it's just balance. Then what is the difference at here, dear? This is positron is positive one. Okay, electron is negative one. This is the difference between these two. And then the other party is different. One is from neutron to proton, one is from proton to neutron. Okay, this is the main key point that they want to test on you. Okay, you have to know about this. So until here, is that clear? Okay, not that difficult, Okay, we goes to this neutrino and anti-neutrino. They are no charge and then they are negligible mass. But why we still have this third particle, we will learn. Okay, the electron anti-neutrino is the antiparticle of the neutrino. So anti-neutrino will be produced during the beta minus. It's called anti-neutrino. Neutrino will be produced during the beta plus. That's all. Okay. So here, boys and girls, question number 1, 2022. We got a cesium 137 decay by emitting a beta minus particle. Okay, try to balance the equation and then tell me PQRS, what is your answer? Easy, easy, just mathematics. Okay, primary student also can balance. Balance the upper part, balance the bottom part. But where you need to start from, you got 4 unknowns. Okay, so can you try and then tell me your answer? Chonghan, yes. How about Q, R, and S? Vashini, correct. Chonghan, second one, correct. Fatima, no. You look at the letter. Be careful with the question. Chonghan, R is wrong. R is wrong. Look at the letter. Okay, Sean. Yes, correct. Sean, correct. Chonghan, correct. Manjo, correct. Yes. Why Manjo? No confidence. Why put a question mark? Okay, Kai-Chen, correct. Right, dear? First, how you should do? You should do for this step first, number 1. Because we know that beta minus is 0, -1. So P is 0, then R is -1. Okay, so this is our first step. Only from here we can balance. So at here, this is 0, here is -1. So Q should be the same, 17137. Okay, the S at here, it should be 55 equals to unknown minus 1. Unknown minus 1. So that means that you need to have a 56 minus 1, then you only get back 55. So this is 56. Okay? So boys and girls, question number 2. Can you try before I tell you the answer? Which nuclide is formed when C10 undergoes beta plus decay? Sean, no. Sean, try again. Chonghan, no. Eh? No. Chonghan, yes. Fatima, yes. Vashini, yes. Kai-Chen, yes. Prasan, no. Why you guys choose D? No? Oh, I know. You guys didn't read the question carefully, dear. Beta plus. Okay, so at here, 10, 6, C, you will decay and get a new product, the daughter. At the same time, you will release beta plus. Beta plus is 0 plus 1, dear. Those you choose D is because I think here mistake lah. Cause the form thing. Jore, correct, Jore? Then, oh, Prasan, oh, yes, dear. Read the question. So at here, 10, so still 10. Okay, this one should be 5. 5 plus 1, you get 6. So at here, the answer should be C. So this part, it should be C. Okay? So step 1, step 2, then you only balance it. Step 3. Manjo, yes. Okay, dear. One more chance. Question number 3. Try again. This is 2024. Question. Fluorine 18 undergoes beta plus decay to form a stable isotope. How many neutrons are there in a nucleus of the stable isotope? Chonghan, yes. Vashini, yes. Fatima, yes. Prasan, yes. Kai-Chen, no. Kai-Chen, maybe some careless here. So at here, 18F9 undergoes plus beta plus, okay, 0 plus 1. If you want to complete, then this is neutrino, okay? If you want to complete, here is neutrino. There is one more neutrino. Okay, then F here, 18, then this one should be 8. So this one unknown. I just give whatever symbol at here lah. So this is our new product, our daughter, okay? Daughter product. So they're asking about neutron. So you should using 18 minus 8. Your neutron number is actually 10. Answer should be donkey. Okay. Manjo, yes. Okay, Kai Chen, did you get it? Okay, can you try with question number 4? Kai Chen, okay. Okay. Question number 4. Uranium nucleus, you got 92 proton, 143 neutrons. The nucleus emits a total 3 alpha particle and 4 beta minus particle to form nucleus X. How can nucleus X be represented? Jore, yes. Okay, dear all, regarding the electricity, the topical past year, the rest of the question, did you complete? If you're facing any problem, you can ask me. Or do you need me to send you my working step for the whole set? The last week, the topical past year. Manjo, no. Manjo, no. Okay. How about others? Prasan, no. Prasan, same answer as Manjo, no. Vashini, yes. Chonghan, yes. Okay, here. 92 proton. So proton right at here, 92. 143. You choose the wrong answer. Is it you just put 142 at top? Cannot, So it should be nucleon number is proton plus neutron. So you should using 143 plus 92. So this one should be 235. So here 235. Okay, this one uranium, I put U. Okay, it will decay and get 3 alpha, 4, 2. Okay, like this. And it will get 4 beta. Beta is beta minus 0, negative 1. Okay, then here, they wants to know how the nucleus X represent. Okay, this one is nucleus X. They form nucleus X. The daughter is X element. Okay, here. Prasan, is it? You are using straightly using 143 put at here. That is careless mistake. Okay, so at here 235 plus unknowns. 235 equals to unknowns plus 3 times 4. 3 times 4 plus 4 times 0. 4 times 0 is 0 lah. No need lah. Okay, 4.0. 4 times 0. So this one is 0. So at the end, what is your value here? The value at here should be 223. So this one is 223. Just balance only. Okay. Then for the bottom part, 92 equals to unknown plus 3 times 2. Then plus 4 times minus 1. So your unknown for the bottom part, you should be able to get 90. So this part is 90. So your answer should be donkey. Actually, it's just balance. The tricky, not really tricky lah. They're trying to trick you is this part only. They give you neutron, so be careful with this. Okay, so those make mistake. Is it okay right now? Can we proceed to the page number 5? Kaichen, okay. Manjo, is it okay? Vashini, okay. Fatima, okay. Manjo, okay. Okay, dear, we goes to your next page, page number 5. An isotope of boron decay to beryllium by beta plus emission. Which particle is emitted in addition to the beta plus particle? This one is theory only. Kaichen, correct. Vashini, correct. Jore, correct. Manjo, no. Manjo, dear. Manjo, no. Fatima, no. Fatima, no. Chonghan, yes. Sean, yes. Okay, dear. Beta plus always together with neutrino. Answer C. Anti-neutrino is together with beta minus. Okay, so this one have to remember. Okay, here, which statement about beta decay is correct? Beta minus decay is correct. Okay, read it. Do not refer. Do you still remember the technique that I teach you just now? Try. Think back. Beta minus is actually what? Change to what? Beta plus is actually what? Change to what? Using the technique that I teach you just now. Jore, yes, correct. Vashini, yes. Sean, yes. How about others? Manjo, yes. Okay, dear. Beta minus, we got two. Beta minus, we got beta minus and beta plus. Am I right? Just now I told you plus is positive. So you start from P. Okay, start from P. Kai Qian, correct. So P is going to N. So this one is N going to P. Get it? Okay, so a neutron convert to proton. This one correct. A neutron convert to proton. Yes. Proton convert to neutron. This is wrong. C and D confirm wrong. Okay, so as I told you, positive. So we start with P, proton. Okay, then what else? Beta minus. So you will have an electron. Electron together with anti-neutrino. So beta plus is positron, positive electron. Okay, so this one is neutrino. So at here it should have a electron and anti-neutrino. So their pairing you have to know. Answer A. Okay, we go to question number 7, 2024. Nuclide X with proton number Z undergoes beta plus to form Y. The decay may be represented by the equation below. What is the proton number of Y and which particle is represented by the symbol W? What is the proton number of Y and which particle is represented by the symbol of W? Oh, Kai Chen, correct. Kai Chen, correct. Vashini, correct. Jore, yes. Sean, yes. Fatima, yes. Okay, all correct. Answer B. Okay, so here beta minus is 0, 1. So your new element at here, this one should be minus 1. Okay, so that minus 1, Z minus 1 plus 1, you get back Z. So this is Z. Okay, so this is A. Then beta plus together with neutrino. Answer B. Okay, Chonghan correct. Okay, dear, we go to your next page, page number 6. A nucleus of a radioactive element emits an alpha particle, then beta particle, then another beta particle. Which statement describes the final element that is produced? Okay, think. Try and then tell me your answer. Fatima, no. Try again. Hai Qian, yes. Manjo, yes. Vashini, yes. Sean, no. Sean, yes. Okay, dear. So at here, it will emit alpha. So let's say right now, I just simply put a value like U, A, and Z. Okay, so it will decay to a new element and then plus. Oh, no space to write. Wait, let me change my place here. Okay, here. So it will have an alpha for 2 and it will have a beta and again a beta. That means that I got total two beta. Okay, beta minus. So it's 0, negative 1 here. Okay, what is my new element? So can you see that we look at the bottom part at here, 2, then plus 2, negative 2. So 2 plus negative 2, actually at here you can remain at exact. The proton number doesn't change. The proton number doesn't change. Okay, then you look at the upper part. A equals to 4 equals to unknowns plus 4. So this one 0, so we don't care. That means that the upper part at here, your A should be minus 4. Okay, at here, that is very important. Can you see that these proton and proton are the same? That means that daughter and parent, they are isotope. They are same element. So at here, this is U, same element. So if they say different element, this is wrong. Why? Because they are isotope. They are same element. Okay, so answer should be C. They are isotope. Same element as the original element, but different number of proton. No, they're having the same number of proton. They are isotope. Okay, is that clear for those answer wrong? Give me the wrong answer. Is that clear for you? If okay, okay, Fatima, okay. So we goes to question number 9 right now. Can you try? Sean. Yes, correct. Vashini, yes. Chonghan, yes. Fatima, yes. Manjo le Manjo. Okay, so this one 2312 mg. So we will decay and we will get 2311 Na. So they will have two particles at here. What is this two particle? Manjo, yes. Kaichen, yes. Okay. So at here, in order to balance, here is 0. Can you see? 23, 23. So it must be 0. Then 12, then 11. Then at here, it must be a positive 1. Then only can get 12. So this one is beta plus. So it's beta plus donkey. Answer is donkey because beta plus together with neutrino. Okay, so when we do partial question, we understand what they want us to know. So this one is plus neutrino. Okay, question number 10. Continue. Can you try and then tell me what was the byproduct of the reaction? John, correct. Chonghan, no. Chonghan can try again. Vashini, correct. Jore, correct. Jore, correct. Okay, so at here, bombarded aluminium with alpha. It not decay alpha, it's alpha hit the aluminium. Okay, it hit the aluminium. So at here, it's not decay, so you don't trying to decay the alpha, no. So this one, it should be 27, 13 aluminium. So it will be add together with the alpha because hit. So this is your front part, okay? Equation at the front part. Then after that, it will produce unstable phosphorus. So this one is P 30, 15, okay? So what is the byproduct? What is this byproduct, okay? What is this byproduct? So we're trying to balance 27 plus 4 is 31. 31, so this one 30, that means this is 1. Okay, then at here, 13 plus 2 is 15. So this one still 15. That means this is 0. What is this, teacher? No proton. But inside the nucleon, this is a proton plus neutron. You get 1. But no proton. This one is 0. No proton. How I know? Because bottom part at here, I know. No proton. So that means that this one, 1 is due to the neutron. So this is N. So a neutron. Answer C. A neutron. Is that clear? 1 neutron. Okay, can we proceed to the question number 11? Yes, Vashini, okay. Haichen, okay. Chonghan, okay. Good job. Okay, can you try with question number 11? Then tell me what could be the resulting products. Chonghan, how many more questions to do? The, 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 the. Do until 9:30. Why you asking this? Just now we did mention about do we need to know their penetrating power and so on? Yeah, this is 2014 question. Okay, where Sean said that answer is B. Correct answer is B. 2 proton. Okay, dear proton, what is the symbol for proton? Okay, proton P, proton. So 2 proton here you write 2. Then inside the nucleus is neutron plus proton, right? So this is 2 also. Okay. So it decays. So it decay the 2 proton radioactive decay of an isotope ion was observed. What could be the resulting product? Okay, so at here this one is Fe4526. So we will decay. Then this one unknown, this unknown. So this one plus the proton, we decay proton. So if you balance, your answer should be B. Okay, your answer should be B. Here, this question I put at here is because I want you to know this is the nuclide notation for proton. Because we never talk about this in year 11. Okay? But you trying to using your common sense. This part is proton number, so we got 2. Then after that, this one we don't have neutron, so our nucleon number also 2. Answer is B. Okay, is it okay? Okay, then next question. Nickel nucleus transformed by a process termed K capture. In this process, nucleus absorb an electron. Then after that, if no other process is involved, what is the resulting nucleus? What is the resulting nucleus? Okay, do it. Chonghan, yes. Sean, yes. Jore, yes. So you need to have the idea, is decay or actually is at the front part, it combined, hit together. Okay, so you need to identify it. So correct, Ashini. The rest of you, do you able to follow? 28 and I. Okay, in the process, absorb. Just now it's bombarded, so now absorb electron. So electron is this one, -1. Okay, then at the end you balance 59, so this one should be 27, so answer should be C. Okay, next question number 13. Okay, do it. Neutrino, anti-neutrino. So gamma radiations. So how do we know which equation is represent the decay? Sean, correct. Okay, we wait for others to complete. Chonghan, no. Chonghan, no. Hai Qian, correct. So Chonghan, yes. Chonghan, yes. Washini, yes. Manjo, yes. Okay, dear, here. Beta decay. They don't tell us it's beta plus or negative. So how should we do? We're trying to see whether it can balance or not. 6 minus 1, it should be 5. So it's wrong. 6 minus 1, it should be 5. So this one also wrong. Okay, this 2 is wrong because of this part. It doesn't balance. Okay, A and B wrong. Then C and D, this one 0 plus 1, 0 plus 1. It seems like correct. You will get 7. It seems like correct. But which one is correct? Beta plus always together with neutrino. No line at the above. So answer should be donkey. Okay. So question number 14. Okay, in a series of decay, then they will decay. So can you find out which statement is correct? Chonghan, yes. Sean, yes. Last one at here. Then we got 1 alpha. So for 2, we got 2 beta. So 0, -1, 2. So you can balance it. Final here. Vashini, yes. Okay, final at here 4. So this one A minus 4. So this one 2 minus 2. So this one doesn't change. This one is similar with just now what we did. Okay, this one should be isotope. Okay, B, isotope. Okay, we go to question number 15. Okay, do your calculation. Vashini, yes. This one, year 11, we did learn about this. So you should know how to solve this question. Starting, then ending. Then we plus unknown. How many alpha here? Unknown. How many beta here? Also unknown. Okay, this one unknown, I can put A and I can put B. So you need to balance the equation using a mathematic way to solve it. Okay, so it's 3, 2, 3, 8 equals to 2, 0, 6 plus 4A. So your A at here should be 8. Then you balance the bottom part, which is the 92 equals to 82 plus 2A minus B. So 92 equals to 82 plus 2A minus B. Your B at here should be 6. So you got 6 beta particle. It should be fine. This is the technique. Starting, ending, then you find how many losing for the how many alpha and how many beta. Okay, here number 16. Question number 16. X is radioactive, so it will decay into the nucleus Y. Then X and Y are isotope. Which combination of particle could have been emitted during the decay process? Sean, yes. So X decay into Y. Then at here, how many alpha? How many beta? Then how do we know? Teacher, it doesn't provide proton number and neutron number. Okay, Vashini, yes. Fatima, yes. Okay, here, keyword at here is they are isotope. So let's say this one is Z. Here is also Z. Okay, then at here, we got the unknown, let's say this one I put B, this one I put C, okay? So we got unknown B and C. So how should we do? The here Z equals to Z plus 2B minus C. So at here Z and Z cancel, so 2B equals to C. Okay, so you look at here which combination can fulfill this. So 2B equals to 1C. So 2 alpha, 1 beta minus. Answer should be C. Manjo C. Okay, here 2 alpha, then 1 beta. Okay, question number 17. What is your T? Vashini, correct. Sean, correct. The rest of you? Unknown plus, I got 2, 3 alpha, 3 alpha, 4, 2 alpha, plus I got 1 beta minus. Okay, so you balance. Da, 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 da. Manjo correct. Kai Qian, no. Kai Qian, no. You balance. So 2, 3, 7 equals to what plus 12? So your answer for this one, you should be able to get A. So Kai Qian, you study again this part. Is it careless? Should be careless. Okay. This one like this. So this one move at here. Okay, this one plus. So this one should be 225. Here should be 88. Okay, question number 18. 9:30 already. We make this question, last question. What is the number of steps in the decay sequence? Correction. How many steps decay? Only Sean get the answer? Right, faster, you guys give me the answer, then we can dismiss. Give me the answer so everybody can enjoy your weekend. Okay, let me have a look. Bashini, yes. Jore, yes. Manjo, did you get the answer? Okay, boys and girls, you just doing like normal. Then after that, you find out how many A. Your A should be 4. How many B? Your B should be 4. What is the total stage? When you decay and emits 1 alpha, this is called 1 stage. So total at here, we got X stage. Answer is B. Okay, today lesson is easy, right? I told you. Okay, chapter 11 is the most easiest one. Okay, then at here, we stop at here for today. And then actually the what? The Chinese New Year, Chinese New Year, we need to find a replacement day. What is the date we should set? Let me have a look. 27, 19, 16, 17, 97. If we make it on 27 is Friday, 28 night, we do one more lesson on Saturday night. Is it okay for you guys? Saturday night, so 7:30 to 9:30. That means that 27, 28, 2 days consequence day, we were having the lesson. Is it okay for you guys? Washini, okay? Okay, then later on I mark down in the group. Okay, we set 28, 27 and 28. Okay, so if no question, then that's all for our lesson today. Bye bye everyone. See you next week.